everyone. Today we're going to be solving multi-step equations when all of the variables are on the same side. So anytime I'm solving an equation, the very first thing I want to do is I want to make sure that I simplify my equation as much as possible before I start doing anything to it. This is going to make it easier to see what actually needs to be done next. So in order to simplify, the first thing I like to do is distribute if I need to, okay? And remember that I can tell if I need to distribute by looking for parentheses. If my equation has parentheses in it, that's a pretty good indication that I need to distribute. So for my first example, I don't have any parentheses. There's nothing there for me to distribute through. But in my second example, I do have parentheses. So I want to make sure I go ahead and do that. So remember, when I distribute, I'm taking my outside number and I'm multiplying by each number on the inside of the parentheses. So I've got 5 times y, which is 5y. I've got 5 times -2, which is -10. And then remember that the rest of this is not included in my distribution. It's not inside my parentheses. It's not touching my parentheses. So it's just going to come down exactly the way I see it. So -7y comes down, equal sign, and -32. So first step, if you have parentheses, you need to go ahead and distribute. Then, after I've done that, I can combine my like terms to make this even simpler. Now, one thing that we need to keep in mind when we're combining like terms is that we can only combine like terms that are on the same side of the equal sign. So if I look at my first example, I have 19 and 7. They're both on the same side of the equal sign, so I can combine those together. They're both regular numbers. I can combine them. I do have a 10 over here on the opposite side, but I cannot combine that with these two terms as well. So I'm going to look on the left side and I'm going to say, all right, 19 and 7 are both regular constant numbers. They don't have variables. I can combine those two together. So I do 19 plus 7, and I'm going to get 26 on that side. Okay. I'm going to look on the right side, and I'm going to see if there's anything I can combine there. Well, the first thing I see is 10. 10 doesn't have any variables, but there's no other numbers over here that don't have variables. So 10 is going to come down. But then I've got -5w and 9w. Both of those have w's, so I can combine those into one term. So I'm going to do -5 plus 9. Okay, I'm going to add their coefficients, -5 plus 9, and I'm going to get positive 4w. Okay, all I've done here is combine the terms that are the same. So I'm looking at my second example. I'm going to combine the terms that are the same. -32 is all by itself on this side, so there's nothing I can simplify over there. There's nothing to combine with. Okay. My 5y does have something I can combine with. I can combine with that -7y. Okay. 5 plus -7 gives me -2y. And then my -10 doesn't have any other plain old numbers, so it's just going to come down. So I've got -2y minus 10 equals -32 for this one. I've got 26 equals 10 plus 4w. Once you've done this simplifying, now you're looking at some two-step equations, which some of us started working on in about 8th grade. So once I've got my two-step equation, once I've simplified and distributed and gotten everything to where it needs to be, now I can start actually solving to get my variable by itself. So the first thing I want to do is I want to add or subtract to isolate the variable term. Now, the variable term is your variable and anything that is connected to it or directly touching it. So in this first example, w is my variable, but my variable term is plus 4w. The 4 is touching the w, the plus sign goes with the 4, so the whole thing is plus 4w is your variable term. Now, I want that to be by itself on one side of the equal sign. Right now, it's not, because this 10 is keeping it from being alone. So I'm going to get rid of that 10 using what we call inverse operations. And inverse operations are just opposite operations that undo one another. So when I add, or when I have adding, I can undo that by subtracting. And vice versa. If I'm subtracting, I can undo that subtraction by adding. Okay, so in this case, I have a positive 10. That 10 is positive, so I'm going to subtract 10 to get rid of those. Remember that with an equation, anything I do to one side, I have to do to the other side. So I'm going to subtract 10 from both sides. 26 minus 10 gives me 16. Make sure you're checking your calculations in a calculator or in Desmos. As we move through these more complicated problems, it becomes even more and more and more important that we're looking to make sure that our calculations are correct. So 26 minus 10 gives me 16. 10 minus 10 equals 0. So those can just go away. And then I didn't do anything to my 4w. So 4w can just come down. Okay. So I'm going to add or subtract to isolate my variable term. Now 4w is by itself. I can move on to the next step. The next step, and the final step, is going to be to add or subtract Nope, not add or subtract. We already added or subtracted. My last step is going to be to multiply or divide to isolate my variable. So I know my variable term is by itself. That's my third step. I already made sure that 4w was going to be alone. So now that 4w is alone, now I can work to just get w. Okay, once my variable term is by itself, I can work to get the variable by itself. Remember, I'm going to use inverse operations to do this. And just like addition and subtraction undo one another because they are inverses, multiplying and dividing are also inverse operations. Multiplication can be undone by dividing. Division can be undone by multiplying. So in this case, I have two numbers directly next to each other. Right now, this is multiplying. This is 4 times w. So I want to undo that multiplication by dividing. Right now it's multiplying. I'm going to undo it by dividing. Well, I want to divide by whatever number it is I want to get rid of. In this case, that 4 is in my way, so I want to divide by 4. Remember that anything I do to one side, I have to do to the other side. So I'm going to divide by 4 on both sides. 16 divided by 4 gives me 4. 4w divided by 4, those 4's are going to reduce to 1. 4 divided by 4 equals 1, which means that I can just write this as regular w. Okay. Now I can check to make sure that this is correct by plugging into my original equation. So my original equation was 19 plus 7 equals 10 minus 5w minus 9w. Okay, I can take my w and plug that back into the w's here and check to see if I get a true answer. So let me show you what that looks like. So I've got 19 plus 7 equals 10 minus 5w. So 5w is 4. I want to make sure I put that 4 in parentheses. Plus 9w. So plus 9 times 4. Again, I'm using parentheses there. And then I'm just going to simplify each side of this. So 19 plus 7 gives me 26 on one side. 10 minus 5 times 4 plus 9 times 4. Again, I'm going to just simplify that side. 10 minus 5 parentheses 4 plus 9 parentheses 4 is going to give us, 745. That's because I typed some craziness in here. Erase that. So I get 10 minus 5 times 4 minus 9 times 4, exactly what I'm seeing right here. And I get 26 on that side as well. If I end up with a true statement, 26 equals 26, that means I did this correctly and that 4 equals W. You should be checking your work every time you do these. It's a great way to catch any mistakes you may have or make sure that you're correct before you actually submit it for grading. So in my second example, I already did the distributing. I already did the combining like terms. So all I have to do is isolate my variable term and then isolate my variable. So in this case, my variable term, my variable is y, and my variable term is y and anything that's connected to it. So in this case, -2 is connected to y, so -2y is my variable term. -2y is not by itself right now because I've got that -10. Well, I need to get rid of that -10, and I'm going to undo that subtraction by adding. So I'm going to add 10 on this side. Remember that if I do something to one side, I have to do it to the other side, so I'm going to add 10 over here as well. -2y comes down. I haven't done anything to it. It didn't change in any way. It's just going to come down. My -10 plus my 10 equals 0, so those are going to disappear. And then -32 plus 10 is -22. Again, very important that you're checking these calculations in Desmos or in your calculator to make sure that you're doing these calculations correctly. -32 plus 10 gives me -22. Now that my variable term is by itself, I can get my variable by itself. My variable is y. Currently, that -2 is keeping y from being alone, so I'm going to get rid of it by doing the opposite. Right now, it's -2 times y, so I'm going to undo that by dividing by -2. And anything I do to one side, I have to do to the other side. -2y divided by -2. My -2's are going to reduce to 1, so those are going to go away. Y comes down. -22 divided by -2 is +11. Again, make sure you're using a calculator to do those calculations. And I can check this by plugging it back in to make sure that I've done this correctly. So 5 parentheses y, but I said that y was 11, -2 minus 7 times y, which is 11. And I'm going to see if that equals -32. I'm running out of space. Okay. And all I have to do is put each side into Desmos to make it one single number. So I've got 5 parentheses another parentheses to plug in my 11, -2, close, -7y, but I know that y is 11, close it, and I'm going to get that that side equals -32. This side also says that it's equal to -32, so that is correct. Now we're going to do some guided practice. I'm going to show you a couple more examples really quickly, and then I'm going to let you do some of this practice on your own. So I'm going to do 1 and 2 and 3 and 4, and then I'm going to let you do some practice. So remember, first thing I want to do is see if I need to distribute or combine like terms or both. In number 1 and 2, I don't have any of that to do, okay? But these are tricky in their own right. Okay? I don't have to distribute, I don't have to combine like terms, but I do need to try to get my variable term and my variable by itself. So for number 1, I want my variable term alone. My variable is p, my variable term is 2/3 p. It's everything that's connected to the variable. Currently, that is not by itself. I have to get rid of the -25. So I'm going to add 25 to both sides. And I'm going to get 2/3 P equals 140. Again, check your work. And then I need to get my variable by itself. My variable is P. And right now this says 2/3 times P. Remember, anything directly next to each other means multiplying. So 2/3 times P. I need to undo that multiplying by dividing. Again, I'm going to divide by whatever it is I want to get rid of. Just like I did here with 4W, just like I did here with negative 2y, I'm going to get rid of 2/3 by dividing by 2/3. Again, this feels weird, but Desmos can handle this. So I know that by dividing by this 2/3 here, that's going to reduce to 1, and I'm going to be left with just P on that side. Then I've got 140 divided by 2/3. Desmos can do this. It's going to look weird, but it is doing the calculation correctly. So 140 divided by 2/3 gives me 210. Okay. Again, I can check to make sure that this is done correctly. All I'm going to do is plug that value into my original equation. So I've got 2/3 times 210 minus 25, and I want to see if that equals 115. So I'm going to simplify each side using Desmos. 2/3 parentheses, scooch out of my fraction, 210 parentheses minus 25, that equals 115. My other side also equals 115, so this is correct. Okay. The other fraction-y type ones that you will see are these like number 2 that are kind of tricky, where the whole thing is a fraction. Okay. When your numerator has your variable in it, I need to get rid of that fraction in order to access that A. Okay. So just like before, I'm going to get rid of the fraction by doing the opposite. So this right now says A plus 7 divided by 8. Well, I need to get rid of that fraction, so I want to undo the division. I undo the division by multiplying. And I want to get rid of the 8, so I'm going to multiply by 8. Okay, so my 8s are going to reduce. They're going to cancel out to 1. A plus 7 hasn't changed at all. It's just going to come down. It's now free of that fraction. 5 plus 8 equals 40. Excuse me, 5 times 8 equals 40. And now I have a variable that I can get to and can get by itself by subtracting 7 on both sides. A comes down. 40 minus 7 is 33. And I can check by plugging this in again. So I've got 33 plus 7 over 8. I'm hoping that that's going to equal 5. And I can check that by simplifying this side. 33 plus 7 over 8. Again, you can put this whole thing in the calculator by opening your fraction first. 33 goes in parentheses, plus 7, and 8 goes in the bottom. And that does give us 5. 5 equals 5, so this is correct. Okay. So those are two-step equations, but they can be a little tricky, so I wanted to make sure that we talked about those. To kind of refresh your memory for number 3 and number 4, I like to use a little acronym that helps me remember the steps. So remember, my first step is to distribute, if I can. Number 3, I don't have to distribute, so I'm just going to skip that step. Then I'm going to combine like terms that are on the same side of the equal sign. So here's my equal sign right here. On this side, I have negative 20 and 5. Both of those are constants, so I'm going to put those together. Negative 20 plus 5 equals negative 15. On the opposite side, I'm looking for things that I can put together. I've got 9x and negative 7x. 9 plus negative 7 is 2x. And then my 1 here cannot be combined with anything on that side. Even though it only has a number, just like these two terms over here, because they are on opposite sides of the equal sign, I cannot combine those together. So plus 1 just hangs out by itself over there. Now that I've simplified, I'm back to a two-step equation. So I'm just going to add or subtract to isolate my variable term. To isolate my variable term. In this case, my variable term is 2x. It's my x and anything connected to it. 2x is not currently by itself because it's got that plus 1. So I'm going to subtract 1 from both sides. Negative 15 minus 1 is negative 16. Make sure you're using Desmos or a calculator to check these. Even if you feel confident, it's always better to double check. 2x, I haven't done anything to, so it's just going to come down. And then 1 minus 1 is going to reduce to 0, so that goes away. And then my last thing is going to be to multiply or divide to get my variable. My variable in this case is x. This is 2 times x, so I want to undo that multiplying by dividing. And I'm going to divide by 2 because that's what I'm looking to get rid of. So negative 16 divided by 2 is negative 8. 2 divided by 2 is going to reduce to 1, and I get 8. Negative 8 equals x. I can check that just like I've shown you before. Make sure that you're going through and checking these answers as you do them. Okay. So sometimes, in order to remind myself of the steps here, I like to do don't call after midnight. Don't call after midnight. Distribute, combine any like terms on the same sides, add or subtract to get your variable term alone, and multiply or divide to get your variable alone. If you come to a step that you don't need to do, for example, in number 3, we didn't need to distribute, all I do is skip over it and move to the next step. So for number 4, I do have to distribute. I know that because I have parentheses. So my y is not part of my distributing, it's just going to come down. My distributing is going to happen right here. And then same thing, equals 76 is going to come down as well. So I take my outside number, negative 3. I multiply it by each of the other numbers on the inside. Negative 3 times 2y is negative 6y. Negative 3 times negative 7 is positive 21. And I can check those in Desmos or in my calculator. Now that I've done distributing, I want to look to see if I can combine any like terms. Well, on this side, on the left side, I have a y and I have a negative 6y. Both of those have y's, so I can put them together. Y plus negative 6, or 1y plus negative 6y, is going to give me negative 5y. Plus 21 cannot be combined with anything else. It comes down. Same thing with 76. Nothing else to combine over here, so I'm done with the combining step. Now I have a two-step equation. So I'm going to add or subtract to get my variable term alone. My variable is y, so my variable term is y plus everything that is connected to it. So negative 5y is my variable term. That is currently not by itself, so I'm going to get rid of that positive 21 by subtracting 21 on both sides. Negative 5y comes down. Positive 21 minus 21 is going to reduce to 0, so I don't need to put that. 76 minus 21, I'm going to do it Desmos. So 76 minus 21 gives me 55. Finally, my last step is to multiply or divide so that my variable is by itself. My variable here is y. Y is not currently by itself, So I need to get rid of that negative 5. Right now, this is negative 5 times y. So I want to undo that by dividing by negative 5 on both sides. Okay. My negative 5s are going to reduce to 1, leaving just my y. 55 divided by negative 5 is negative 11. And I am finished there. Okay. I want you to go ahead and try 5, 6, 7, and 8 on your own, based on the ones that I just did. Feel free to look back and take a look at the notes that we just did while you work through this. Copy these 4 onto your paper, give them a try, and then come back here and check your answers against my answers. All right, for number 5, you should have gotten negative 6. Remember that you need to get rid of that fraction first, so I want to multiply by 9 to get rid of that distributing, to get rid of that dividing. In number 6, I want to get rid of that 5 first, so that my variable term, x over 4, can be alone. And then, once I have x over 4 alone, I want to get x alone. Currently, that's x divided by 4. I want to undo that dividing by multiplying. So I get x equals negative 12. For 7, you should have gotten x equals negative 4. Make sure to combine your like terms here in that first step. And number 8, you should have gotten x equals 5. Make sure you're doing that distribution before you start solving. Go ahead and try these 4. Remember that the general steps for this are to see if you need to distribute. Okay, remember we can use don't, call, after, midnight to help us remember the steps. D reminds us to distribute. C reminds us to combine like terms on the same side. With A, we want to add or subtract. To isolate your variable term. And M, we want to multiply or divide. To isolate the variable. Okay. There actually is a typo in number 10, so I want you to go ahead and skip that one altogether. Don't worry about doing number 10, but I want you to continue to practice by doing 9, 11, and 12. Copy them in your notebook, solve them through, and then come back here and check your answers against my answers. All right, for 9, you should have gotten negative 4. For 11, you should have gotten negative 16. Remember that this is a negative 5 being distributed, so make sure you keep that in mind as you do your multiplication. And then for number 12, you should have gotten negative 3.5 or negative 7 halves. Now, I know we're not always used to getting decimals for these types of questions, but that does not mean that it's not an answer or that it's not correct. Okay? Just because you get a decimal doesn't mean you've done this incorrectly. So one of the best ways to check and make sure if you've done it right is to go back in and plug it in. So I'm going to do that right here with this one. So I've got negative 4, parentheses 2p. I said that p was negative 3.5. If you did this as a fraction, even better. Minus 1, close it. And I'm hoping that that's going to equal the same as 41 minus 9. 1 minus 9, running into my other stuff here. So now that I've plugged it in, I can just check it in Desmos. I'm going to simplify the left side. Negative 4, parentheses 2, parentheses 3.5, negative 3.5. Close it, minus 1. That equals 32. And then my other side, 41 minus 9, also equals 32. So this is correct. Don't let the fact that you got a decimal or the fact that you got a fraction make you think that you did it wrong. While most of the time we will get a whole number here, we also have to be aware that it's not always going to be a whole number. So double check your work and plug it back in and see if you get the right answer. And that's a pretty good indicator that you've done this correctly. Okay. The last little thing we need to talk about is word problems that we then need to solve. So this is kind of combining what we did when we translated and this solving part. So I'm just going to show you these two examples really quick. So we want to translate first and then solve. So number 13, 12 decreased by twice a number equals negative 34. So remember that 12 is going to be 12. Decreased by tells me that I want to subtract. And be careful here because decreased by is not a turnaround word. So it's just going to be 12 minus twice, which means 2 times, a number. In this case, I want to use x. So twice a number is going to be 2x equals negative 34. Okay, so now that I've translated this, I can solve this to figure out what the number is. So I've got 12 minus 2x equals negative 34. I don't have to distribute. I don't have to combine like terms. So I can just roll into adding and subtracting to get my variable term alone. I'm going to subtract 12 to get it by itself. Negative 2x comes down. Negative 34 minus 12 is negative 46. Okay, you can check that in your calculator or check that in Desmos if you're not sure. And then I can get my variable alone by dividing by negative 2. And I get x equals negative 46 divided by negative 2, which is 23. Okay, I'm going to apply that same process to number 14. This one's got a lot more words, but the process here is the same. So among the career home run leaders for Major League Baseball, don't care. Okay, don't care about this. This doesn't tell me anything relevant to my problem. Hank Aaron has 175 fewer hits. Okay, so Hank, I'm going to put a big H to represent Hank, has 175 fewer hits. So fewer means I'm going to take the number of hits and I'm going to subtract 175. 175 fewer hits than twice the number that Dave had. So 175 fewer than twice of what Dave has. Okay. So Hank has 175 fewer than twice of what Dave had. Then in the second part it says Hank Aaron hit 775 home runs. So now I know what H is. 775 equals twice of what Dave had minus 175. How many home runs did Dave hit? So I'm trying to figure out what D is. Fortunately, I can just solve this. I want 2D to be my variable term. I need that by itself, so I'm going to add 175. When I do 775 plus 175, I'm going to get 950 equals 2D. And then I can get D alone by dividing by 2. And I'm going to get 475 equals D. Okay. So remember that with word problems, we want to answer these questions. So the question said, how many home runs did Dave Winfield hit? So I'm going to answer that by saying Dave Winfield hit 475 home runs in his career. Okay, we're going to do some more practice with word problems, but I just wanted to give you a little preview of what that's going to look like. So if you have any questions, make sure you write them down and bring them to class so that we can discuss them together.